Good afternoon, good evening, good morning. Hello, everybody. Thanks for joining us. My name is Josh Long. I work on the Spring team as a Spring developer advocate, a Kotlin Google developer expert, and a Java champion. And yes, I do know Glenn. It's one of the reasons why I feel very lucky in my life. I feel like I've lived a pretty great life if I know people like Glenn, and of course, Jakob and Nate, of course, two of my inspirations. So it's really good to be with you all today. We're gonna, I think we're gonna kind of, you've seen a lot today, right? No doubt. But what I was hoping to do is just to kind of look at back to basics, look at Spring Boot, and kind of focus on why I think it is the best time to be a Spring and JVM developer. I'm going to do that ever so quickly by, of course, building some software. But before we do that, find me online, friends. I'm very online, like achingly online. I got a YouTube channel. It's not great. It's not great, but you could do worse. There are worse mistakes you'll make today, probably. So there's that. And the reason I mention that is because I don't know how long this Twitter thing's gonna be working. It feels like it's crumbling every day. So join me on the internet. It'll probably be fine. We can have the conversation. That way, even though our time together right now is limited, we can still have the conversation and continue the conversation after our brief window of time here. Okay. So, friends, I really wanted to talk to you about this latest and greatest generation of Spring Boot. I think we're in an amazing moment in the Java ecosystem, and that's because, frankly, I don't know that we've ever had. There's never been a better time to be a Java and Spring Boot developer, and I say that fully cognizant of the fact that we had, that we celebrate this year 20 years of Spring, right? And you might have already seen this, the history of Spring. It's a little side scroller game you can play that shows you the sort of history of Spring. And look at that, we're going down now. We're going all the way down, going through, racing through it, going into the cloud, right? Spring Cloud released, all that kind of stuff. We got going back down here. Now we got the water, Kubernetes, maritime themes, all that kind of stuff. Spring Cloud Gateway for Kubernetes, and then of course 20 years. So I say that we're in an amazing time for Java and Spring Boot developers, fully cognizant of that fact, right? That it's been 20 years of amazing releases. And I think the only way to kind of appreciate that is just to, as usual, go to my second favorite place on the internet. Friends, we're going to build a new application. We're going to use Maven because right now Java 21 doesn't work quite well enough with Gradle. But normally we use Gradle, and that's fine. And that brings us to the version of Java that we want to use. Friends, there are 4 versions down here, 4 radio boxes, but only 2 of them actually work. You see, Java's 8 and 11 are not supported for Spring Framework 6 and Spring Boot 3.0 and later. So these 2 right here, these are just for the memes, just for the lulz, just to find out who makes terrible life decisions. You should never, ever use these. Java 17 and 21 are technically superior in every way. They're faster, more robust, more syntax rich, more operations friendly, more container ready, more secure. They're technically superior in every way. They're also morally superior. You won't like the look of sadness and shame in your children's eyes when they realize that you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use at least Java 21. Now, friends, I'm going to be using some of the new cutting-edge features in Java 21, so I'm also going to use the 3.20 M3 release of Spring Boot. And then we have a choice of what we want to name our thing. I'm going to call it Service. And the reason I'm going to call it Service is because I'm really, really good with names. I get this from my father. My father was also really great with names. When I was a boy, we had a small white dog, and my father named him White Dog. Now that dog was with us for like 10 years, and then he disappeared. And I don't know what happened to him. Maybe he got a job. I don't know. But either way, that little white dog disappeared, and then another white dog appeared, and my father named him Two. And I'm not sure if it's TOO or TWO, but either way, great with names. Although that said, my mom tells me all the time to this day that I'm very lucky that she named me. And yeah, that's probably true. So we're going to go ahead and add some GraalVM-native image support. We're going to add the actuator. We're going to add the web support. We're going to add Postgres. We're going to add the Testcontainer support. We're going to add dev tools. We're going to add the data JDBC support. We're going to add all this stuff, okay? I think I'm happy with my selections, though. So do I have a web? I don't think I have web. Oh, I do have web. Yeah. Let's go ahead and hit generate then. And we'll open this up in the IDE. And it doesn't all that much matter what IDE you use, so long as it supports this. Let me go ahead and get rid of all that. Okay. UAO service.zip. Okay. Come on. So we've got a brand new public static void main application. I want to start making changes and coding and all that stuff. But friends, I'm all about living that git clone run lifestyle, right? So I have a new application, service application, and I could start here. But let's first take a brief moment to look at what's in the source test folder. You see, I've got test containers on the class path. And so I have my unit tests, of course, but I also have this public static void main class that's in my source test Java code. This is meant to be run during development. And here I've got, test time only specific dependencies, a bean on of type Postgres container that is a test container object, right? It's using the Docker API to launch Docker images. And this is a bean that will only exist during development. So I can actually start up the Spring Boot app and it'll start up my database. And then it'll do me one better. It'll actually create a connection to that database using this @service connection annotation. This annotation connects my database, connects my Spring Boot app to the database that was just created when the application started up, right? Very, very convenient. Now, the thing is, I also want to use dev tools. Dev tools are a great way to make changes and to do live reloads. The trouble is, of course, friends, that dev tools, it works by recreating the bean factory each time you recompile the code, and you can see the changes instantly, right? It works great if and only if you don't take a long time to restart your bean factory. And of course, what's going to take a long time when you restart it? Well, Postgres, right? I mean, that's fair. Postgres isn't supposed to be restarted every 5 seconds anyway. It's not meant for that kind of workload. So it takes a little while to run. And so we need to tell Spring Boot, don't restart that bean. Don't recreate that one bean. Let that survive across restarts. And you can do that with @restart scope. Okay. So now we can use this main class here, this test main class. We're going to say Maven Spring Boot test run. Okay, so it's going to run the program for the first time. And it's going to take a long time. You can see it's spinning up the Docker image, talking to the database, all that kind of stuff. There you go, 3.2 seconds, okay? But now we can actually go back to our production code, and we can start making changes, okay? So here, I'm going to build an entity of type customer here. And this is really nice. I like this style. I'm using records here. And honestly, friends, I think I don't want to mislead you here. I don't want you to think this is the extent of Java records. There are so many amazing new features that are in Java 21 that sort of culminated in Java 21. A lot of them got introduced in piecemeal in earlier versions. And so as an example, let's take a little domain, a hypothetical domain, and just a little tangent here, a little digression, because Java 21 now supports what Java language architect Brian Getz is calling data-oriented programming. And the core conceit there is that most of Java's history, it has thrived in the world of the monolith, right? The large code bases with lots of modular components, because it has a good type system, and it has a good access and visibility controls and so on. And so in the world of deeply seated hierarchies of code, Java has always been sort of a very natural thing for large teams to work on. That said, increasingly programs today are more small, as they're smaller in nature. They're dealing with ad hoc data coming in off the network. They're dealing with different kinds of stringly typed payloads, JSON objects and things coming in off of a Kafka or RabbitMQ or whatever. All these things are sort of data centric, and then increasingly the code bases themselves are smaller, and increasingly the communication between parts of the system is being done in terms of these messages, these data objects, not in terms of these deep hierarchies, these abstract interfaces that used to be so common, right? And so there's got to be the language has to adapt to meet this new challenge, and it has. It has introduced a number of things that, taken together, give you data-oriented programming. Okay, so we're going to take a look at those ever so briefly, right? Ever so briefly, and we're going to spell them out one by one. Okay, so pattern matching, switch expressions, smart switch expressions, record, and sealed types. So let's take a hypothetical. Okay, let's suppose I have a loan. Well, loans are usually in a bank or a finance institution. Loans are heavily regulated. You want to make sure that when you add a new loan, that you care for that particular kind of loan in all the code base, all the places in the code base. Okay, so let's suppose I have a new loan, but I don't want people to just add any arbitrary loan. I want them to have to be very, very explicit about it. Okay, I don't want somebody creating an anonymous interclass loan to get by certain type checks that would otherwise not pass, right? So I'm going to create a sealed interface loan that's going to permit only two subtypes, okay? I'm going to say class secured loan implements loan, and unsecured loan, okay? Good. And then we're going to say secured loan and unsecured loan, okay? So there you go. I'm now explicitly only permitting those two types. Now, the compiler is saying, hey, these things could be subclassed. So you need to either make them final or further define that they are sealed. Okay, so good. So the compiler is now happy. It's saying, okay, I know exactly which two implementations of this thing exist in the code base. Now, let's say I wanted to change this implementation. I could use a record. Maybe that has a variable, some state, right? And interest. I can't type that word to save my life. Okay, here we go. Good. So the nice thing about records is that records are data objects. They're carrier objects. The identity of the object can be constructed by the component, the constituent component fields of the object. So here I've got a field called interest. Well, that means that secured loan, its entire identity is this interest field. If I add another one, then I can say that the combination of interest and name equals secured loan. They are the same. In this way, records are sort of nominal tuples. They're tuples that have a name, right? And so this is a very convenient way to describe data. And if we're willing to reduce the assumptions that this object implies down to just it is its data, it is its own state, the state is the identity of the object, then we can get some nice benefits from that if we're willing to assume those prerequisites. One thing we can get is a toString method, equals method, a hash code, all that kind of stuff, okay? So I've got now a record, and let's say I make this one as well a record, okay? Records are implicitly final, so I don't have to do anything special there. So interest, okay? Good. Now let's say I want to create a message based on the loan you've got, okay? So string loan message, okay? Given a loan, okay? So I could say, okay, if loan instance of secured loan, and then I could do the worst. I could say SL secured loan loan, right? I could downcast, but of course that's been a no-no for a long time. I could just do this now. I could say SL, right? So now I've got a context-specific access to that particular type downcast to secured loan, okay? That's better. So maybe I can say, okay, let's say var message equals this, and I can say message equals you've got a secured loan. Well done, okay? I like it when my financial institution is encouraging. Okay, and then I could say, okay, if loan, instance of unsecured loan, okay? And maybe I could say, better luck next time, sport 100% interest for you, something like that. Okay, good. Now this is a simple if-else kind of thing. I should add an else because they're exclusionary. But it works. In this case, we know that I've covered both cases. But what if I were to go back here and add another kind of loan, right? This wouldn't catch this. This wouldn't catch that at all. So instead of doing this, let's use the new smart switch expression, okay? And the way this works is I say, I'm going to switch on the loan. Okay, here we are. Case UL. And I'll pass this in here. I'll say, take that, put that over here. Good. And then what about the secured loan? Okay, and then where's this message here? Okay, put that in there. Voila. Good. So now this is much cleaner. I think we can agree. var message equals these two things and just return the message. So now the language is helping me because I've extracted out I've extracted the message by analyzing the types. If I comment this out, look at that. The compiler is unhappy. It's saying you didn't exhaust all the possible input values, right? So it's treating the hierarchy, the sealed hierarchy, in much the same way it would treat an enum, right? Have you seen this trick, right? Day of week. There's exhaustive checking for enums, right? So day of week dot Friday, and then I can say switch DOW, and I can say case Tuesday, whatever, right? And it's going to complain because it doesn't know that I've covered. It's not a statement. Well, whatever. Var message equals that, whatever. Okay. There you go. So it doesn't. It's complaining that I haven't covered all the possible enum values, and the same is true now for our sealed type hierarchy, right? I can now be assured that I have covered every single use case. Otherwise, the compiler will bark at me. That's very good. So now in this heavily regulated industry, I'm not just adding new loans nilly-willy. Okay, what about this? I've got the interest. Okay, I've got it hard coded, but I actually want to look at the interest rate. So I could actually say, ul.interest and then add that in, I guess. But if I only need the interest, I can actually use pattern matching to hoist that into its own variable, right? Now I can just say interest. Voila. Very nice, right? So now I've got this very concise syntax. I don't have to deal with a full unsecured loan. I can extract out the component parts of the object. So these things taken together, pattern matching, smart switch expressions, records, and seal types, all together, they give us data-oriented programming. So we're not going to do a lot more of that, but I just want you to know, when you see me just want, easily and quickly create these little records, that is just the beginning. It's just the first step into a whole new journey. Okay, friends, we're going to create a customer repository that extends a list of CRUD repository managing customer entities of type customer with primary key integer. We're going to create a customer HTTP controller, private final customer repository. We'll inject that into the constructor like so. Voila. Okay, and then we're going to create a get mapping endpoint customers collection of customer, and we'll say return this dot repository at find all. Very good. Okay, now I'm going to create a simple HTTP controller at response body. And there we go. There's our simple HTTP controller. Now I want to talk to the database. So I'm going to initialize the database with some schema. So I'll say SQL init always. Okay. And then I'm going to write a schema file. So I'll say schema.sql. Okay. Create table if none exists. Customer ID serial primary key name varchar 255 not null. Very good. Okay, so there's my schema. I'm also going to put some data in there. I'll say data.sql, and I'll say delete from customer, and I'll say insert into customer name values. Josh. Who else is on the Spring team? Jurgen, of course. Wrong one. There we go. Stefan. Olga. Violetta. Adura, Yushin, Spencer, etc. Okay, so that's 8 names. That's you can divide by 2 and then 2 again. It's still 2. I love it. It's a very nice round number. Good. So we've made our changes. We got our data. Let's go ahead and do a reload. I'm not going to recompile everything. I'm just going to do a reload. And so you can see that was 0.4 seconds, a far sight faster. Thank you. So I've got coffee now, friends. Oh, so good. So I have localhost 8080 customers. Okay, there we go. So there's our data. It's worked. Safari is unhappy about the accents, but it does work. Good. So now I've got this. It's pretty stock standard stuff. We're moving quickly. Git clone run, test containers, data-oriented programming, good stuff, but all fairly typical. I'm sure you've seen something like that before, but things have not stood still. So obviously, if I wanted to, I could do some of the more modern, more interesting stuff. There's new opportunities out there, right? One of them, of course, is AI. So I'm going to go ahead and just quickly introduce that into our program. Here, I've got this dependency here. I'm going to take that dependency and I'm going to add this repository here. Voila. Okay. Spring Snapshots. It's an experimental project. Spring AI, OpenAI, Spring Boot Starter. That'll require a full restart. That's not a dev tool. That's a class path reload. So we'll do that again. Reload that. Okay. But now in my code, I can actually create a new, let's say, AI endpoint. So class AI controller, private, final AI client, singularity. Okay, singularity. Good. Inject that into the constructor. And let's create a story. Let's have it create a story here. Okay, so story map string story time. Okay, we'll say return map.of story, and we need this. Okay, var story equals this.singularity.generate, and I'm going to provide a prompt. Okay, and by the way, there's a whole new category of engineering around how to ask the AI a question in such a way that it gives you a response that you can deal with it, right? That you can deal with it. And so, it's called prompt engineering or prompt engineering, right? It's pretty amazing. Like, for example, I'm going to ask it just a plain text thing, but you can actually get it to give you data in a data interchange format that you can use in your code. So that's pretty interesting. Okay, let's say, dear Singularity, please write a story about the amazing Spring Boot ecosystem, its many open source contributions and contributors. Okay. Also, please do it in the style of famed children's author, Dr. Seuss. Cordially, Josh. Okay. Okay, so we're going to ask it to tell us a story. Okay, Command Shift F9. Let's go ahead and load this up. So, story. And we'll just wait. We'll just wait for that result to come in. Oops. What happened? 500 error. Oh, I know what's happening here. Am I on is it the Wi-Fi? Do I want to risk it? Wait. Hold on. I've got to wait. Boom, 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 boom. Do, 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 do. Okay. Wait for it. Hello, can you hear me? Yep, can you hear me? Woo! Can you hear me? Okay, am I live again still? Oh yeah. Sharing is caring. Okay, so what happened was I put on the VPN. That was my bad, and I did that so I could get past the local internet restrictions, so I could punch out and get this story from the AI Singularity. Apparently, some people haven't had that revelatory, eye-opening moment about the awesome opportunity that lay in AI. But anyway, in the meantime, I got this back. Dear Josh, in the land of coding where the hackers roam, there lived a framework called Spring Boot, oh so well known. With its vibrant ecosystem, it stood tall and proud, contributions aplenty, making the coding world loud. Oh, the wonders of Spring Boot, let me tell you, my friend, a framework that made developers' hearts mend. Open source treasures, freely shared by the masses, contributors working hard in coding glasses. First, there was Spring Data, making databases hence, with its seamless integration, giving developers a chance to connect with SQL or NoSQL, oh so easily. Storing and retrieving data, oh so breezily. You get the idea. It can tell stories, friends. It's an amazing time to be alive. So now we've got the freaking Singularity. We got git clone run, test containers, all this kind of stuff. And I made that request. You couldn't really see that I made that request because I guess I, used the VPN and got myself kicked out of the live stream. But just trust me, because I've now disconnected from the VPN, so I can't do it again. But just trust me, it took a long time. It took several seconds. And what's happening from the perspective of our program when I make that request? Well, think about it, right? We're on line 36. Okay, great. And then we go to line 47, and I make the request, and then we're blocking, aren't we? We're making a call to another network service, and we're calling input stream.read on a socket, pointing to some endpoint on the internet, right? And when we call input stream.read, well, we block, right? We can say that the program is stuck waiting for that response to arrive. When will it arrive? We don't know. It might be tomorrow, might be the next week, might be a second from now, it might be a nanosecond. The point is we're stuck. Hopefully you've got some timeout code in there, but basically you don't know. And this is bad enough, but it's made worse by the fact that right now in the JVM, up until recently, if you sat on a thread, that meant that you were taking something very precious and depriving the rest of the system from it, right? Threads are expensive. It used to be that they took about 2 megabytes of space for each thread. So we did a lot of work. We did whatever we could to sort of avoid the use of threads, right? To avoid wasting time on threads. So we looked at in Java 1.4, we had NIO, and then Java 1.7, we had NIO2, and then my friend Tristan Lee over in Korea, he's a fellow Java champion. He created Netty. Netty is a non-blocking I/O library, one of the most widely and prolifically used libraries in the Java ecosystem, along with Spring and JUnit and like Log4j and whatever. And so that was a great way to think about it, but it was a little low level. So people worked with higher order programming paradigms like reactive programming. But even that, it's different. If you're not used to reactive programming, you're not going to love that experience. And so, wouldn't it be great if we could have our cake and eat it too? Well, in this case, we can, right? There's now something called Project Loom in Java 21. So let's take a brief look at that, okay? So just another digression here. And I'm going to borrow this example. I stole it shamelessly from Java developer advocate Jose Omar. Okay, Omar, right? I think it's that one. I think it's that one, but actually, I'm now doubting myself. Anyway, Jose Pomar, that's his name, and that's pronounced correctly. I'm just not sure if I'm spelling it correctly. So we're going to create a bunch of threads. Okay, I'm going to say int stream range 0 to 1,000, and we're going to map each one to a thread. We're going to create a virtual thread. Okay, so of virtual dot unstarted new runnable dot to list. Okay, and so I'm going to create a bunch of threads, and then I'm going to go for each thread t.start, and then do the same thing and join. Okay, and I want to run each thread, and when I'm running them, I want to note on which thread I'm executing. Now that seems like a ridiculous thing. Like, why would that change? Well, let's see. So I'm going to note which thread I'm executing on. Here I'll say observed.add note index. Okay, and we'll create this method here. Good, and we're going to say return thread.currentThread.toString. If index is equal to 0, return the current one. Otherwise, return that. So basically, I'm only going to sample the very first of the 1,000 threads, but I'm going to sleep so that I force contention, so that there's not enough actual operating system threads in the system. So I need to do interleaving, right? Time sharing. And so that's going to force the runtime to try and figure out how to make it work. Well, it's got a new quill in its bonnet. It's got a new trick up its sleeve. What it's going to do is it's going to move us from one thread to another transparently. Okay, and we can see that here because I'm logging out the thread. So let's do Command Shift F9, go to the console, and you can see it ran. Ignore that, right? That's the empty space for all the other threads. But here, virtual thread is the same. So for the first thread, the thread with index 0, for the very first thread, it's virtual thread 122. Okay, 122. Virtual thread 122. So we can see I was on virtual thread 122 the entire time, and that makes sense, right? I was as far as I know, I'm on the same thread here, here, and here, and I am on the same virtual thread, but I'm no longer on the same carrier thread. That's the magic trick here, right? So I'm on carrier thread 1, worker 2, 1, worker 5, 1, worker 9, etc. You get the idea. I'm being moved off of threads. The compiler is automatically rewriting blocking operations. I'm doing thread.sleep or input_stream.read. All these are blocking operations. It sees that we're doing those blocking operations. It's moved us out of the flow of the code and moved us into RAM. And then as soon as the blocking thing is finished, it's putting us back. But that same thread that we were using before might no longer be available. So it's moving us to some other thread. And it's all transparent to us. You don't see me spinning up and switching out to different threads here at all, right? It's just happening behind the scenes. This is the power of Project Loom. It means that we get the same kind of scalability as we might have gotten with reactive programming without having to change our code. Well, that's not exactly true, is it? We had to change a little bit of our code, thread.virtual. And most of us don't create threads directly. And if we do, we create them like this. We use an executor service. And then in the Loom world, you'd use that. So this is not even a thread pool anymore. It's just a thread executor, actually, which is not as, it doesn't sound like what it is. It's kind of like what Jakob was talking about, the open versus closed circuit being the opposite of what it actually does. Counterintuitively, same thing here, right? This is not an executor. It doesn't kill threads. It actually launches them. Okay, and it creates virtual ones, and it doesn't pool them either. It just creates brand new ones each time because it can do that. It's very efficient, right? There's no reason you can't create millions of threads with Project Loom. But even as simple as this is, there's still a lot of places in Spring and in your frameworks that use executor services. So if you're using Spring Boot 3.2, you can just do this. You can say virtual threads enabled equals true, and it'll automatically switch out these executor services all throughout the framework to use this new thing. Okay, great. So now we've got data-oriented programming, git clone run, test containers. We got dev tools, making changes quickly. We've got Project Loom, unparalleled scalability. We got the freaking singularity in there. I mean, we're just doing really good. Okay, friends. That said, I think we need to focus on getting this thing into production. And what are some of the things we can do? Well, maybe I want to create a new endpoint here. Customers, name, collection of customer by name, path, variable, string name, return this.repository, find by name, passing in the name. Okay. Now, obviously, the problem here is I don't have this type in the class path, so I'll let the IDE do the walking. Take that, ChatGPT. Okay, and we got Josh, and voila. Okay, there's our data. It worked fantastic. So now I've got this new endpoint. Now I want to make sure that this is production worthy. So one of the things I might do is have a little bit of validation, a little defensiveness, right? I want to say that the name has to be, uppercase. Okay, so caricature is uppercase. The name must be uppercase. Okay, great. What happens if that is true? Well, it's going to throw an exception of type illegal state exception. And so I might want to have a controller advice here, class error handling, controller advice, exception handler, void handle, passing in that exception. Now I want to create a consistent representation of the error in the system. So I'll use this problem detail type. This is a standard here, problem details RFC, right? This one right here. So this is a standard for representing errors in an HTTP API. So I'll do that. So I can say pd problem detail dot for status HTTP status dot bad request dot value return pd, and maybe I'll do a pd dot set detail ISE dot get localized message, and voila. Okay, there's that. And so now let's just see that in action. Curl HTTP localhost 8080 / customers capital Josh. Okay, that's worked fine. Great. Now, what about I do lowercase? Okay, pipe that to JQ for pretty formatting. There you go. So I get a problem details compliant representation of the error. Nice. So I've got this nice little upgrade in Spring Framework 6 here. What else could I do? Maybe I can inject the current request. And what would I do with that? Well, maybe I get the header names and I get the iterator and I visit each one and I just print out the results like that and Command Shift F9 and make the same request. And you can see that when I make that request, there you go. I can see the headers, right? So there's the headers. That's fine. Why do I care about that? Well, friends, this is our old friend, the servlet request, but it has moved home. It now lives in the capital of Indonesia, Jakarta. And to understand why, we need to cast our minds back, far, far back, before the COVID pandemic, BC. There was a weird moment in history where the Oracle Java EE sort of people just stopped working on it overnight. They didn't tell anybody why. They didn't telegraph it. They just ghosted the Java EE community. And this is really bad because Oracle, by dint of having acquired Sun Microsystems in the 2000s, they were the lead of a number of different specifications, including old favorites like the servlet spec and JMS and JPA. So this meant that nothing could be done because they weren't involved in the process, and they had to be involved in the process because they were the leads. Eventually, they came back to the table. They open sourced it and gave it to the Eclipse Foundation. And there, in order to eschew any sort of problems, they repackaged everything under a new package, a new domain, a new namespace called Jakarta. So what used to be Javax dot is now Jakarta dot. Just be aware of that when you upgrade. Okay, so we've got now the new types. We've got the error handling. What else can we do? Well, you saw Nate and Jakob talk also eloquently about the observation API and the new unified support for that. So I'm not going to bother here, but you can definitely introduce the actuator support, the observability support with micrometer. But otherwise, I think we're ready to go to production and to package it up. And the first question that we have is, how do I package the application up to be a Docker image? And here, friends, obviously, just use build packs. That's a answer that didn't need the question, right? We already know, right? Build packs are a great way to package up your application and turn them into a Docker image. Remember, friends don't let friends write Docker files. Don't do it. Be the change you want to see in the world. Do the right thing. So this is part one. The next thing is, how do we make our application as fast and as efficient as possible? And friends, I just want to take a brief moment to establish that I think that Java is already phenomenal. It's just an amazing language. And I think this blog from 2018 BC well epitomizes that fact. This blog reviews a paper which looked at the question, which programming languages use the least electricity? And this blog, this paper, had a great table here. And it says that, C for energy is the most efficient for machines, okay? Not for people. For machines, it is the most efficient. Great. Rust, zero cost abstraction, is doing well. Good job. Well done. C++, tui, disgusting. I'm not even going to talk about it. Moving on. And then we got Ada, but who cares? And then we got Java. And Java is, 2.0. Let's round up, okay? Simple math. 2.0. Good job. It's twice as inefficient as C, or C, put another way, is twice as efficient as Java. So we're already doing quite well. We're in the top 5 most efficient languages. And remember, C, Rust, and C++ are very, very different creatures than Java, right? This is the fact that these languages don't have runtimes should tell you a lot by just how good Java is. And yet, the results are also pretty interesting. The other results, you got C#, okay, good. You got Go, away. You've got JavaScript and TypeScript. By the way, I don't understand this. If you, like me, use TypeScript, then you should know that we are in the same boat, and our boat is sinking. Look at this. This is 21 versus 4. I thought this compiled into that. I don't know. I have no earthly idea how this got so inefficient. Then we've got these two disgusting languages, the less said about which, the better, of course. And then we've got this here, JRuby and Ruby. Remember, JRuby is the Ruby interpreter written on the JVM. And Ruby is the Ruby interpreter written in C. And so the JRuby, JVM-based implementation of Ruby is like, what is that, a third more efficient? I mean, it's phenomenal how good being on the JVM is. It's just a privilege. We get so much benefit from that. This came later, by the way. It's not like they had a head start in developing the JRuby implementation. By definition, Ruby came first, and JRuby is the derivative work, right? And it came years later. I mean, and yet it's still much more efficient. And then we have this one, Python. I love Python, my friends. I love it. I've been using it since Bill Clinton was president in my country in the 90s, right? More than 20 years I've been using Python. And yet this number is not good. We really need to have a conversation about this. Let's just round up again. 76, okay? We're going to round up to the nearest number. I'm going to call it 76. So I'm not very good at math, but you know who is really good at math? Python. So let's ask it. Say 76 divided by 2. That's 38. What that means is if I wrote a program in Java and that program resulted in a little bit of carbon, the electricity to power the program resulted in a little bit of carbon being captured in the atmosphere. And that carbon caused the earth to get just that much warmer. And then that killed one tree. Well, the same program in Python kills 38 trees. That's not good, people. We need to that's especially with the rise of AI. This is worse than Bitcoin. That's not good at all. It's really, really bad. I forgot what we're talking about. Oh, right. Java. Java's very good, friends. It's just really, really an amazing result. And I think it's an amazing result for two things. One, of course, is that we have this amazing Java programming language garbage collector. I think that's an amazing piece of software. It allows us to write sort of mediocre code and kind of get away with it, which is really, really, really appreciated. That said, I do take issue with the notion that it is the original Java garbage collector. I think that honor belongs to this person. Her name is Jesslyn. She's from the island of Java, Indonesia. and she is the Java garbage collector. I love this joke. I love this tweet because look, there's 20,000 people liked it. That's awesome. Usually the internet is a terrible, terrible place, but sometimes we get wholesome humor like this, and I'm all for it. Well done, internet. Well done. Anyway, the Java programming language garbage collector is a phenomenal piece of technology. It's one of the reasons why Java is so efficient and so scalable. The other is the just-in-time compiler. And the just-in-time compiler looks at frequently accessed code paths and optimizes them by turning them into operating system and architecture-specific native code. It struggles where the code risks introducing new types that weren't there. That is to say, it needs to know about the integrity of the type system before it can optimize the code. So things that violate that integrity, things like reflection, serialization, JNI, resource loading, and JDK proxies, these things cause issues for the just-in-time compiler. But it's still a pretty good result. So good, in fact, that large organizations like Google and Alibaba and the rest, they will take this code and take their code, deploy it, send a lot of traffic to it, and then spin up the application. Send traffic to it, and then let loose real production traffic on the resulting JITted application. It's an amazing result. But one wonders, if the result is so good, then why not compile everything to native code ahead of time, AOT. And of course, I think you probably know this, but there is a way to do that. There's something called GraalVM. GraalVM is an open JDK distribution with an extra few utilities, including the native image CLI. The native image CLI is an AOT compiler, but it also struggles with these dynamic things. And there are ways around it. You can furnish JSON configuration, okay? JSON configuration. But there's a couple problems with this, for my friends. First of all, I just don't like saying it. It sounds stupid. I speak French. In French, you would say a JSON, which you have to admit, it sounds cooler. It sounds much better. So I don't like saying JSON. I cannot believe that adult people say that word to each other. It just sounds ridiculous. A JSON at least sounds cooler. But I was just in Taiwan, and there they have a language called Hokkien, and there they have the word Jingsong, which means happiness, right? Which is also fine. I like this one too. Either way, let's get rid of JSON. That's my message to you, friends. That's what we need to do. Okay. The other thing is, there's just a lot of it. There's just a lot of JSON required for any given application, and it gets very tedious. I don't have enough time to write all that JSON. I don't even have enough time to finish this talk. So thank goodness there's a new feature in Spring Boot 3.0 to create that for us, right? So let's go ahead and use that. We'll go here, and I'm going to use this compiler feature here. We'll say profile is native, skip test because I didn't write any tests, and we're going to let that run, and it's going to take its sweet time, and it's going to compile. And this is actually my least favorite part of the whole thing, if I'm honest, friends, is it just takes a long time, and it's long enough, in fact, that I get kind of restless. I get kind of bored. I finally understand this cartoon, the XKCD cartoon, the famous XKCD cartoon, the #1 programmer excuse for legitimately slacking off. My code's compiling. And then the boss says, hey, get back to work, compiling. Oh, carry on. I didn't get this joke before, people. I thought this was just the C++ people. I thought it was them. I didn't know it was going to ever be us. 2023 is a weird year. Anyway, so now I get it. I get this joke. I didn't want to. And it's really annoying because it's not enough time for me to get up and go to the bathroom or make my own cup of coffee or something like that. But it is enough time that I'm kind of just stuck there. And eventually, I feel like I'm blocking, kind of like the threads from earlier, actually. But at least those threads got relief in the form of Project Loom. Where's my relief? I don't know. But anyway, it's gotten to the point now where I kind of get bored and I stare at the wall, and maybe I'll hum game show theme songs or hum elevator music in my head. And it's gotten to the point now I actually hear the elevator music in my head. And I thought, gosh, wouldn't it be great if everybody could hear elevator music? So I went to Oracle and I said, Oracle, buddy, please play elevator music during the native image compilation process. I already hear elevator music in my head while I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And then I got some great responses, including this one from our friend over at Red Hat, Andrew Din. Andrew Din is a distinguished engineer, a Red Hat Java team, on the Red Hat Java team. He's an OpenJDK project reviewer, a Byteman project lead, and a Graal developer. So obviously, this was a good use of his time. And he said, please, can you make it this elevator music? I'm not going to play the music because it links to the GoldenEye Nintendo 64 video game for the first Pierce Brosnan outing as James Bond. So there's a movie in the 1990s, there's a Nintendo 64 video game, and there's a soundtrack. And this is from the soundtrack for the video game, for the movie from the 1990s. Great choice. I liked it a lot. Well done. Somebody else said, I would add that using beeps in general, not only for native image, really helped me to reduce development time. Yeah, that's a great idea, actually. That's a really good idea. My stupid microwave will make a ding sound when it's done. Why can't my multi-million line compiler? That's a great idea. I'm all for that one. And then I got this response. And this is from Dr. Niephaus. He's another one of my favorite doctors, along with Dr. Sire, Seuss, Strange, Subramaniam, DeVolder, Pollock, and Sire. And he said, he's a researcher on the GraalVM team at Oracle Labs, and he said, thank you for the feature request, Josh. The problem with playing music during your compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Anyway, he continues, I have prototyped a -- Josh Long mode. Let's see what that looks like, friends. So you have this image, right? This is a picture of what's happening, but just remember, there's music playing. Don't forget that, right? So you run the native image compiler, -- Josh Long mode, hello world, and then there's music playing, and it says music brought to you by Josh Long. That's me. I'm Josh Long, okay? And then, of course, you want something nice to look at, so then it'll print this out in the meantime. And I'm sure that'll get merged any day now. So I forgot what we're doing. Oh, right, the compile. Let me see. Oh, there we go. So it finished several minutes ago. This is awkward. Wow. Okay, well, anyway, it's been done. So let's go ahead and run it, okay? So service, good. Okay, the first time it failed because the port's already in use. That makes sense. Let's go here. Where's my application? Okay, I'll stop it. Now we can start again. Okay, this time it failed because it couldn't find the database. That makes sense as well, right? It's we did git clone run, Testcontainers, all that good stuff. So I need to plug in a database. So I've got this script here, cd desktop talk cat run.sh. It's going to export some environment variables and then run the binary, right? User JLong download service target service. So that's, look at here, user JLong download service target, etc. So I'm going to go ahead and do docker compose up and run that. Okay, there we go. There's our application. You can see it's up and running. 0.143 seconds or 0.15 seconds. So much less than a second, less than 0.2 of a second. And that includes the full web server and all that stuff. And we got virtual threads, we got native images. I don't actually care about the startup time so much, though. What I care about, friends, is the resource footprint. So let's take a look at this. This is the process identifier, 38587. And I'm going to measure the resident set size, okay? This is measured in kilobytes. So you divide by 1,000. So let's say resident set size, okay? Good. And yeah, it's measured in kilobytes. It's the RAM, basically, measured in kilobytes. So divide by 1,000, okay? So there's the number. Let's run it. So it's 116,000. So call it 116 megabytes, okay? That means that our program is taking about 116 megs of RAM. That's like 1/20th of your average Slack or Microsoft Teams installation. That's 5% of what Slack is probably using right now. That's an amazing result, my friends. And that's just all we had to do was upgrade. We're using Java 21. We got virtual threads. We got unparalleled scalability. We've got a small, tiny little binary. We've got some of the most concise code in the business here. There's never been a better time to be a Spring and Java developer. I hope I've persuaded you of that. I hope you see some of the opportunities. I want to thank you so much for your time, and I hope you had a great show, and thanks for hanging out with us today.